Hello and welcome. Have you ever stopped and wondered how your email provider just knows what junk mail is? It feels kind of like magic, doesn't it? Well, today we're going to pull back the curtain on that magic. We're going to demystify the whole machine learning thing by building our own simple AI spam filter, right from scratch, step by step.
So here's the game plan. We'll start by defining the problem, then we'll set up our model, train it, test it, and for the grand finale, we'll use it to predict a brand new email. All right, let's jump right in.
First things first, we need to frame the problem for our machine. You can't just tell a computer to find the spam. You have to give it a really clear, learnable challenge.
It really does feel like magic, right? An email pops up and poof, it's already sorted into the junk folder. But you know what? It's not magic at all. It's just a process. It's a machine that's been taught to see patterns by looking at tons and tons of examples. And we're about to build our own tiny version of that exact process.
Okay, time to start building. Now, for any project, you need your tools and your materials, right? Well, in machine learning, it's pretty similar. Our tools are algorithms, and our materials, well, that's data.
The main tool we're going to be using is a classic algorithm called logistic regression. It is perfect for what we're doing because it's really good at classification tasks. Sorting things into two neat little piles. For us, the question it's going to learn to answer is simple. Is this email spam? A yes, or not spam? A no.
And here are our raw materials. This table you see? That is the entire textbook our AI is going to study. It's a super small data set, just 6 emails. We've turned each one into a string of numbers. A 1 means a certain word is in the email, a 0 means it's not. And that last column, the Y column, that's our answer key. 1 means spam, 0 means it's legit.
These words, and, vaccine, the, and so on, we call these features. The best way to think of them is as individual clues. The presence or absence of each word is like a little signal, and our model's entire job is to figure out which of these signals are actually important for spotting spam.
So right now, our model is a total blank slate. Seriously, it has no opinions, no knowledge, nothing. All of its internal settings, which we call parameters, or theta, are all just set to 0. It's basically an empty brain, totally ready to learn.
And now for the really cool part. We're going to take our empty-headed model and teach it how to tell the difference between spam and real email, and we're going to do it using only that tiny table of data.
The way it learns is through this simple but super powerful loop. It's often called gradient descent because you're trying to go down the hill of being wrong until you get to the bottom. Here's how it works. First, the model makes a guess. Then, it compares its guess to the right answer to see how wrong it was. Finally, it just slightly adjusts its own settings to make a better guess next time. It does this over and over, getting a little bit smarter each time.
So, on its very first attempt, with all its settings at 0, the model is completely clueless. I mean, it has absolutely no reason to lean one way or the other. So for every single email, its first guess is just a coin flip, a 50-50 chance, a 0.5 probability of being spam.
Okay, here we can see the learning happen in real time. Let's just focus on the word vaccine for a second. For email A, the model was wrong. It guessed 0.5, but the right answer was 1 for spam. So the error is negative 0.5. And since the word vaccine was in that email, the model thinks, maybe that word had something to do with why I was wrong, and it calculates an adjustment. It's like the model is learning which clues were at the scene of the crime.
So after it does that for every single email, we just add up all those little adjustments. The grand total comes out to -1. This number tells the model which direction to nudge this one specific parameter to get less wrong in the future. We then take that total adjustment, that -1, and we use it in a simple little learning formula to update the setting. And there it is. The new weight for the vaccine parameter becomes 0.5. I mean, this is it. This is the moment the model has learned its very first lesson. It's realized, hey, the word vaccine might mean an email is spam.
Now, we do that exact same step-by-step process for every single one of our features. And what you're looking at here is the model's new, slightly less empty brain. It's figured out that vaccine in Nigeria probably means spam. That's why they have positive weights. And it's even learned that the word of might actually mean an email is not spam, so it gave that one a negative weight. Pretty cool, right?
All right, training's done. Our model thinks it has figured some stuff out. But did it actually learn anything useful? Let's put it to the test and see if its new knowledge actually works.
So we take our new, updated parameters and we run our 6 emails through the model one more time. But this time, instead of guessing 0.5 for everything,
It calculates a very specific score for each email based on what it learned. If the score is over 0.5, it predicts spam. If it's under, it predicts not spam.
And would you look at that? It worked! The predicted labels in that last column are a perfect match for the true labels. After just one single pass through the data, our little model has learned to perfectly classify every single email in our training set.
Now this is all fantastic, but here's the thing. The real test of an AI isn't if it can memorize the answers to a test it already studied. The real question is, can it handle something new, something it has never, ever seen before?
So let's pretend a brand new email just hit our inbox. It's got the words vaccine and Nigeria, but none of the others we're tracking. We turn that info into its numerical fingerprint, its feature vector, which is what you're seeing right here. The model takes this new fingerprint and applies everything it just learned. It sees a 1 for vaccine and for Nigeria, so it multiplies those by their positive weights. All the other words aren't there, so their weights don't matter. It crunches the numbers and spits out a final score, 0.731. And since that score, 0.731, is way above our 0.5 cutoff point, the model makes its final call. It confidently labels this new email as spam. It actually worked. It generalized what it learned from old data to make a smart prediction on new data. And that is it. We did it. We defined a problem, we got some data, we trained a model, we tested it, and we used it to make a real prediction. We built a simple AI. So that just leaves us with one last thought. Now that you've seen the basic recipe, data, features, a learning loop, what other yes or no questions out there could you teach a machine to answer? Really, the possibilities are pretty much endless. Thanks for watching.